Hi friends, today we will be discussing about the causes of climate change. The causes of climate change is more important for us to understand the science of climate change for simple reason that we need to attribute the causes either to the natural processes or human induced processes, and this attribution of climate change is the fundamental or bedrock for understanding the climate change, the concept and science of it. In this regard, if you look at it, the causes can be either natural causes or human actions, human activities. And today's session will be discussing about the both causes, the natural causes and human induced causes. We know that the Earth's climate is not static, always changing. Since its formation, Earth's climate was changing due to natural drivers of climate change. However, the human action and activities in the post-industrialization era resulted in increases of radiatively active gases in the atmosphere, leading to increase in the global surface temperature. And we know fully well that since industrialization, the amount of fossil fuel use, the activities of human beings in terms of urbanization, industrialization, and whatnot, everything has changed the landscape of Earth. And the main driver is the use of fossil fuels. And the consequences of enormous use of fossil fuels is what? Climate change. Due to the increase in the radiatively active gases into the atmosphere. The anthropogenic induced climate change is a cause of great concern due to its potential impacts on the environment and also on the biospheric components of the environment, whether it is a terrestrial ecosystem or an aquatic ecosystem. At any given time, the Earth's climate is subjected to a number of influences. It can be the natural or the human-induced causes. Some of them are natural and some of them are caused by the humans. When you look at the natural drivers, such as the solar activity, they are very much part of an overall repeated cycle, and they impact climate over a very long period of time. It can be tens of thousands to millions of years, and that is the main, the background of natural drivers, because their impact, if you wanted to understand, if you wanted to go in depth into the natural drivers, we need to look at the past climate in geological time scales that will be in a position for us to figure out that the natural drivers, how important it is causing climate change in the past. Some events like the volcanic eruptions and impacts from the celestial bodies also, like asteroids, have immediate effect but are one-time events. And they are also natural causes, and they not influence the global climate for more than a few years. So this is about the natural causes in terms of volcanic eruption and also the celestial body impact, particularly the asteroid impact that has taken place in the past. When you look at the human drivers, when you compare the human drivers with their natural causes, they are different in fundamental ways. And this human influence is happening very, very rapidly, and it is not cyclical in nature, and it pushes the climate continuously and relentlessly in the single direction of warming, and that is the great impact of human beings on the global climate change. And that is the reason why the gravity of the situation compels us to go for the mitigation aspects, mitigation of the greenhouse gas emissions from human actions. The important natural drivers of climate change in the industrial era or the changes in the solar irradiance, volcanic eruption, and the El Nino and southern oscillations. However, there are other known natural drivers of climate change which operate on a longer geological time scales, and they are very, very important. They are called as Milankovitch cycles or Milankovitch oscillations. Let us see one by one the natural causes. The first and foremost important natural cause is the solar activity or solar variability. The sun's energy appears to be constant but undergoes small little changes over an extended period of time. There are different types of solar activities, such as sunspots, solar flares. The sunspots are relatively cool, dark spots appearing periodically in groups on the surface of the sun, while solar flares or storms, eruptions of hot gases from the surface of the sun, accompanied by a burst of UV radiation, ultraviolet radiation. So these sunspots and solar flares also influence the solar output or solar activity, and that can consequently impact the Earth's climate. The sun goes through roughly 11-year-long periodic variations in the frequency of sunspots, solar flares, and other solar activity. During this period, 11-year period, the sun goes through a solar maximum and a solar minimum. During a solar maximum, the sun has the maximum number of sunspots and solar flares, and it gives off more of energy. The inverse is true in case of the solar minimum, wherein the sun has only fewer sunspots and solar flares. So in case of solar minimum, it gives off less energy, but in case of solar maximum, the energy, the solar output or solar activity will be much higher, and that can influence the Earth's climate. The solar activity affects the Earth's climate. We have a lot of examples in the past. In the recent few centuries back, between 1650 and 1850, the Little Ice Age occurred, and this Little Ice Age is believed to have been triggered off due to decreased solar activity. Further, it was reported that about 3 billion years ago, it's very long back, 3 billion years ago, the solar radiance was only about 80% of the present value. Only 80% of the present value. Think about it. The solar activity was much lesser, but there was warming. And the reason was that then the atmosphere was rich in carbon dioxide, the most important greenhouse gases. It is particularly the carbon dioxide concentration is because of the photosynthetic activity that has taken place in the biosphere in the past. The solar constant exhibits a small little variations, periodic variations, about 1 watt per meter square due to sunspot activity. The solar output vary with respect to the number of sunspots, as I said earlier, and this can have an impact on the Earth's climate. It is reported that the sunspot cycles have wavelengths averaging 11 years. That's called the SQUAB cycle, varying between 8 and 13 years. The 22-year cycle, that's called Halley magnetic cycle, and the 37.2 years cycle, it's called Looney solar radiation, and 88 years cycle, Gliesberg cycle. See, these are all the things happening on the solar surface, and this also has to be taken into account for attributing the changing climate. It is reported that a persistent anomaly of 1% in the solar constant could change the effective mean temperature of the Earth's surface by as much as 0.6 degrees centigrade, provided the Earth behaves as a black body. So 1% change in the solar activity, solar constant, that can have an impact in terms of changing the surface temperature, in terms of increasing the surface temperature to the tune of 0.6 degrees centigrade. That has to be taken into account in the present circumstances also. If you see it, how important it is, because since the industrialization, if you see, the human actions has caused a change in the climate to the tune of 1 degree centigrade. Further, it is reported that the solar variability caused changing climate in the past, before the industrialization era. The second important thing is the orbital variations, popularly called as Milankovitch oscillations. Way back in the year 1930, the relationship between the orbital variations and the Earth's climate was proposed by Milankovitch. The orbital variations influence the amount of solar radiation reaching the Earth's surface, and also the distribution of the sunlight vis-a-vis the regions and the seasons. The Milankovitch oscillations are important from the perspective of understanding the past climate, including the ice ages and also the interglacial periods. It's a very important oscillations, very important, the cause, the orbital variations. That is so wonderful that we can understand easily the past climate the changes in the past climate because of how the orbits, whether it is eccentricity or obliquity or wobbling of the earth, how it has changed the climate in the past. Shape of the Earth's orbit oscillates from elliptical to circular orbit with a period of about 1 lakh years, and this is called as eccentricity of the orbit. And due to the eccentricity of the Earth's orbit around the Sun, the solar energy received on the Earth's surface varies between the perihelion and aphelion. The Earth's tilt angle also varies between 21.5 degree and 24.5 degree with a period of 41,000 years. The present degree, the Earth's tilt angle is 21.5 degree, and this varies between 21.5 degree and 24.5 degree. This is called as obliquity, and this also can cause the variations in the climate. The third is the wobbling of the Earth's spin. That's called precession, and this involves a period of 23,000 years. The third important natural cause is the tectonic processes. Look at the mountains, look at the Atlantic ridges, mid-Atlantic ridges, or seafloor spreading, mountain ranges, whether it is Himalayan, Rockies or Andes, all have been caused because of tectonic processes. When you look at the events on the Earth's surface on geological time scales, you can find the position of continents and the oceans have changed due to the Earth processes, tectonic processes. The theory explaining the movement of continents and oceans is popularly called as plate tectonics. These movements of lithospheric plates, it's a huge lithospheric plates, have caused formation of mountains and changed the size and location of mountain ranges and plateaus. These tectonic processes has influenced the atmospheric circulation pattern and also the ocean circulation pattern, because I just talked about the mid-Atlantic ridge. So that also, this kind of tectonic process that has taken place in the deep inside the Earth's surface or the ocean basins, that also can influence the changes in the ocean circulation pattern. The same is the case with the atmospheric circulation also. It was reported that the ice age episodes such as the Permo-Carboniferous glaciation of Gondwana period were due to the changes in the continental location. Further, the desert conditions observed in the western part of China and Central Asia was attributed to the uproot of Himalayan ranges and also the Tibetan plateau. The next important cause of climate change is volcanic eruption. Due to volcanic eruption, large amount of sulfur dioxide, water vapor, ash and dust particles are thrown up into the atmosphere. This is a very important thing because water vapor is a very important greenhouse gas. The other particles, aerosols, will have an impact on the global climate because of its radiative properties. The tiny ash and dust particles from the aerosols in the atmosphere, which reflect the solar energy back into the space, have a cooling effect on the planet. The equatorial eruption plumes spread into both hemispheres, whereas plumes from the eruptions in the mid and high latitudes are confined to that hemisphere only. Records of such eruptions are preserved in the Antarctic region and also Greenland ice sheets for at least last, if you look at it, 1.5 lakh years. It has been preserved. And looking at that particular data, looking at the records of these kind of ashes, you can definitely decipher the past climatic conditions. And it's a very, very important thing as far as the proxy climatic factors or indicators are concerned. The observational evidence from the last 100 years demonstrates that the major eruptions cause a hemisphere or a global cooling of 0.5 degrees centigrade to 1 degree centigrade in the year following the event, but there is strong regional variability. The 1992 to 1994 cool spell is attributed to the increased reflection of the solar radiation caused mainly by the eruption of Mount Pinatubo Island. The radiative forcing of volcanic aerosols is reported to be greatest for only a short period of time, for instance 2 years, followed by the volcanic eruptions. So, in this session, we have discussed the natural causes of climate change. how natural causes of climate change are important with respect to the past climatic condition. I'm talking about the climatic changes that has taken place in the geological time period. The main important causes we have discussed are the solar variability, the solar activity, and the second one is the orbital variations or Milankovitch oscillations, and the third is the tectonic processes that play tectonic movement, and the fourth is the events like volcanic eruptions. So when you look at these causes, definitely the four most important causes you will be coming to know is that solar activity and the orbital oscillations. These two are very, very important, because by looking at these two causes, understanding more and more these two causes, we can decipher the past climatic condition, because the past climate is the key to the present climate, and we can understand the future climate in a much better way only when we understand the causes of climate change. So in this session we have seen only the natural causes. In the coming session we'll be talking about the human induced causes, particularly the changing greenhouse gas concentration in the atmosphere, the land use changes. Yes, land use changes also is equally important as far as the human actions and activities are concerned. Thank you.